Okay, this is my last installment for Lab 3 for right triangle trig. I've done 2 videos where I've done some of these main problems. This video I'm going to start at number 27, which is really we're kind of applying our right triangle trig using word problems. And a lot of times to do these, the hardest thing sometimes is drawing the picture. So I wanted to help you. So I think I'll start at number 26. So I have a hot air balloon, and it's tethered to the ground by a cable 250 feet long, so that the cable makes an angle of 57 degrees and 20 minutes with the ground. So when I first tried to draw this, I'm going to say this is my balloon up here. I drew the right triangle, and I get this is the ground here, and here's my right angle, but I didn't know which one to label the cable until it said that the cable was 250 feet long, and it made an angle here of 57 degrees and 20 minutes with the ground. So that's where it goes. It said find the altitude to the nearest foot, and the altitude would be right here. It's from the ground up to the balloon. So my balloon is right here, and that's what I have. Once the picture's drawn, you're going to do the same thing we did everything else. You're going to label it hua. So this is my H. Across from my angle is O, and the ground is A. And I see I have things by the O and the H, so this is going to be sine. So the sine of 57 degrees and 20 minutes is going to equal opposite over my hypotenuse. And then basically you're just going to cross multiply and put this right in your calculator. So you're going to put in 250, the sine of 57 degrees and 20 minutes. And when you do, you're going to get 210.45. So x to the, if I'm going to round it to the nearest foot, is going to be 210 feet. So here you're actually using it. All right. Here's number 27. A support wire is attached to the top of a 42-foot telephone pole. So that's a little bit easier. Here's my telephone pole. I know my telephone pole is 42 feet because that's what they said. And the wire is attached to a stake on the ground. So this one I think is a little bit easier to draw. And they say the angle formed by the wire and the pole is 35 degrees and 10 minutes. It says find the distance from the stake of the foot of the ground to the pole. So they want us to find here, the ground. All right. So I'm going to label it hua. So H, O, A. I see I have stuff by the O and the A. So this is going to be the tangent. So I do the tangent of 35 degrees, 10 minutes is opposite over adjacent. And here you're going to cross multiply and say, okay, x times the tangent of 35 degrees and 10 minutes is going to equal 42. And then you're going to divide by that. So x is going to be 42 divided by the tangent of 35 degrees, 10 minutes. So when I put that in my calculator and they said go to the nearest foot, it comes out to be 29.59. So this is roughly going to be 30 feet. Okay, so those are those two. On the next page, I like doing these two. So here's 28. It says a ladder 24 feet long leans against a building and it makes an angle of 71 degrees 50 minutes with the ground. So that's cool. So here's my buildings over here, and I'm going to make this my ladder. Sometimes my right triangles are better than others. So here's my right triangle, and they said it's 24 feet long, and it leans against the building at this angle of, I'm going to have to do this because I wrote it's kind of small, 71 degrees and 50 minutes. So that's almost 72 degrees because there's 60 minutes in a degree. And they said find to the nearest foot the distance of the base of the ladder to the building. So they want us to find here. So I'm going to label it hua, H, O, A. So everything's by A and H. So this is going to be cosine. So the cosine of 71 degrees 50 minutes is going to equal x over 24. So now I'm going to cross multiply. X is going to equal 24 cosine of 71 degrees 50 minutes. And when I do that, I find out that that's going to be 7.482. So it's roughly, said nearest foot, 7 feet. Okay. 29. This one's cool because we're kind of still talking about a ladder against a building. So I have a 20-foot ladder. I like this one. This one's a 20-foot ladder leaning against the building. So this is 20 feet. Here's my right angle. And side of a house, sorry. And if the foot of the ladder is 5 feet away from the base of the house, find to the nearest degree the measure of the angle the ladder makes with the ground. So here they want the angle. So I know I'm going to have to use an inverse trig function. Still, I'm going to label it HOA, H-O-A. And they want us to find the angle, so I have stuff by A and H. So I'm going to use cosine here. So cosine of angle X is going to be 5/20. And I know that reduces down, but don't worry about that. So now I have to find the angle, so I have to undo this cosine with an inverse cosine. If I do it, I have to do it on both sides. So thanks for playing. X is going to equal inverse cosine of 5/20. And then when I put that in my calculator, don't forget when I'm doing this in my calculator, I'm actually coming up with the angle. So this is in degrees. So this is 76 degrees. So I hope this helps. I've done a few of each kind so that you can finish this lab. So good luck.